Okay guys, so this is going to be your free response set number 2 notes. Once again, the last question, actually the last question on here is going to be for BC only, so AB, ignore it. Okay. So first part of this question, this is a solids revolution question. It says find the area of R. Okay, so when we graph this, we're going to graph it and we're going to find our intersection points first. Let me change my window. So when you go to graph this, you're going to change your window, your X values from 0 to 1 and your Y values from 0 to 1. Okay, so that first graph is going to be your square root of X and your second graph is going to be the exponential function. So I would just label that Y is equal to square root of X and Y is equal to e to the negative 3x. Now, you need to find that intersection point. So we're going to do second calc, intersect. We're going to go close to the intersection point, hit enter, 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 and it's going to occur at 0.2387. So we're going to be using that limit quite a few times. Now, this is all a calculator, so we're going to integrate from 0.2387 to 1, and it's going to be top curve minus bottom curve. So square root of x minus e to the negative 3x dx, and we're going to math 9 this. So we hit math 9 vars y1 minus y2, comma x, comma 0.2387, comma 1, and we get 0.4427. Part B, it says you want to find the volume of the solid when it's rotated about the line y is equal to 1. So y is equal to 1 is up here. So we draw our ladder, and there's going to be white space. So we're going to do top curve minus bottom curve, and we're going to have an R big and an R little. So your R big extends the whole length of the ladder, so it's going to be 1 minus e to the negative 3x. And your R little is going to be 1 minus square root of x, because we've got to get rid of the white space. Okay, so let's set up our integral. Volume is equal to pi times the integral from 0.2387 to 1 of r big squared minus r little squared. Okay, so what I'm going to do is I'm going to put my R big in Y1. And I'm going to put my R little in Y2. Okay, and so I'm going to quit. I'm going to math 9 vars Y1 squared minus Y2 squared, comma x, comma 0.2387, comma 1. And then I'm going to multiply it by pi. Wait, I did something wrong. Hold up. I had that 9 in there. Math 9 vars y1, comma y1 squared minus y2 squared, comma x, comma 0.2387, comma 1, and then multiply it by pi. So you should get 1.4236. And don't forget to multiply by pi. Okay, part C. It says the cross sections are going to be perpendicular to the x-axis and they're a rectangle. Okay, so volume of rectangle is length times width, or base times height. So same limits, no pi this time. And our length is 5 times the base. Okay. Now your base, whenever we're doing cross sections, is always your top curve minus bottom curve. So it's going to be 5 times b squared. Okay. B times b is b squared. So your base is going to be square root of x minus e to the negative 3x. We're going to square it. like that. And we're gonna put that into y1 square root of x minus e to the negative 3x. Okay, we're gonna quit and we're gonna do math 9, and we're gonna do y1 squared, comma x, comma 0.2387, comma 1. And then we're gonna multiply it by 5. Okay, so you should get 1.5544. Okay, so hopefully we're pretty good at these. We spent a lot of time on free response with this. Okay, next one deals with velocity and acceleration. So once again, this is a calculator question. So I'm gonna start by just going and putting my velocity function in to my y equals. Make sure you're in radians. You have to be in radians when you're in calculus. Okay. Okay, so it says find the acceleration of the particle at t is equal to 2. Okay, so for part A, v prime of 2 is equal to a of 2. So the derivative of velocity gives you acceleration. So what I'm going to do is I'm going to do math 8 vars, comma, y1, comma, x, comma, and I'm evaluating it at 2. So a of 2 comes out to be 1.5876. Okay, and we don't have any units, so don't worry about the units. Now, it wants to tell if the speed of the particle is speeding up or slowing down. Okay, so v of 2, we're just going to plug into our table. Okay, so our table, plug in a 2, you should get negative 2.7279. Now, remember what we said is if the velocity and the acceleration have opposite signs, that it's slowing down. So opposite signs means slowing down, or the speed is decreasing. Okay? Part B. It says find all the times between 0 and 3 when the particle changes direction. So a particle changes direction when the velocity is equal to 0. Okay? So what we're going to do is it says we're going to change our window. It says from, let's see, zoom, 6. It says from 0 to 3. So our graph, if we go from negative 10 to 10, is going to look like this. And we're going to want to change our window, the x, from 0 to 3. Okay, we want to know where it's equal to 0. So we want to find the 0 that crosses right there. So we do second calc 0. And we're going to go below. Hit enter. Above, hit enter. Enter again. So t is equal to 2.5066. And it's going to go from negative to positive. Okay? So, goes from negative to positive, sorry. Okay, portion C, it says I want to find the total distance traveled from 0 to 3. So, total distance traveled is the integral from 0 to 3 of the absolute value of your velocity function. Okay, so we go to do this, we're going to do math 9. That brings up our integration. And then to do absolute value, you hit math, number, ABS. Everything stored in Y1. Close that, comma X, comma 0, comma 3. And you should get 4.338. Okay, so that's total distance traveled. Part D. It says, during the time interval from 0 to 3, what is the greatest distance from the between the particle and the origin? Okay, so this is asking for a max or a min. okay? So if we go back to our graph, from negative to positive, we had a max or a min, okay? It should be a min because it's going from negative to positive. So that's where the greatest distance away from the origin is gonna occur. So if I wanna find that position or displacement, I integrate the velocity function, okay? And we use our first FTC. Okay, so we're gonna integrate this. So we can do math 9 vars y1 comma x comma 0 comma 2.5066. Okay, so you should get negative 3.2655. And this is what we're looking for. And x of 0. X of 0 from our original function up at the top, it says it has a position of 1 at t is equal to 0. So we're going to add that 1 to the other side. Now, when we integrate velocity function, we get something called displacement. Displacement is the distance from the origin, okay? So if we're talking about distance, it's actually going to be a positive number, so it's 2.265 is our answer. Okay? The negative just means it's in the negative direction. Okay. Part A and part B of this question are pretty easy. They're going to be pretty standard on a lot of these tests. Okay. So it says use the data in the table to estimate the rate at which the number of people waiting in line was changing at 5:30. So 5:30 isn't going to be on this table. You know, it starts at noon. And 5:30 is going to be located somewhere in between those 2 points. So to estimate the slope, L prime of 5.5, we're going to do 150 minus 126 over 7 minus 4. And you should get 8 people per hour. Now, when we do this, to get your units, you always do the y units over the x units. Okay? And it says show and indicate units of measure. Okay, so that's part A. Part B, it says use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours. So your first 4 hours are right there, and we're going to do our subintervals, like we always do. Now it says average, so this is looking for average values. So 1 over b minus a times the integral from 0 to 4 of L of t dt. So the integral of L of t dt is going to be your trapezoidal sum, and then we're just going to divide it by 4 at the end. Okay, I'm going to go through this quickly with setups. You can put this in the calculator on your own time. Okay, remember that the area of a trapezoid is 1/2 the height times b1 plus b2. Your height is going to be your delta x is right here, and your b1, b2 are right here. So your first one's going to be this one plus this one. Second one's going to be this one plus this one. Third one's going to be 176 plus 126. Okay, we should be good at those by now. Okay, part C. It says from 0 to 9, what is the fewest number of times that L prime of t must equal to 0? Okay, L prime of t is equal to 0 at a max or min. So that means it's going to go from increasing to decreasing or decreasing to increasing. Okay, so from 1 to 4, we can see that oh, it's going to go up to 176, and it's going to go down. So you have to have a max in there, so that's 1 time. Okay, and then from 3 to 7, okay, so it's going to decrease, and then it's going to increase again, so you're going to have another, you'll have a min, and then it's going to increase, so it's decreasing, increasing, and then it goes decreasing again. So you're going to have another max in there. So at least 3 times. Okay, so on that, once again, so the derivative is equal to 0 at a max or a min. So we can see that this is increasing, increasing, and then it's going to decrease, and then it's going to increase again, and then it's going to decrease some more. Okay, so it has to have at least 3 times where the derivative is equal to 0. Part D. Okay, part D. It says the rate at which tickets were sold from 0 to 9 is modeled by the function. And you want to know how many tickets were sold by 3 p.m. to the nearest whole number. So all we're going to do is we're going to integrate 0 to 3 of 550t e to the negative t over 2 dt. And I put in the calculator. So 550x e to the negative x over 2. So math 9 bars y1 comma x comma 0 comma 3. And you should get 972.7841, which is 973 tickets. Okay, so remember when we integrate a rate, we get an amount. And so in this case, it's asking how many tickets are sold. What's the amount of tickets sold? Okay. Next question. Okay, I'm going to be honest with you on this one. I really don't like part D of this question. It didn't really make a lot of sense to me as I was going through and doing it. So, anyways, I'm just letting you know as I go through and explain this. So it says a metal wire of length 8 centimeters is heated at one end. The table gives selected values of the temperature in degrees Celsius and the wire in centimeters. The function is decreasing and twice differentiable. Okay, so it says estimate t prime of 7. We should be really good at this. 7 is located in between those 2 points, so t prime of 7 is equal to 55 minus 62 all over 8 minus 6, which is a negative 7/2 degrees Celsius per centimeter. Okay, we should be really good at that. Shouldn't miss that ever. B, it says write an integral expression in terms of T of x for the average temperature. So we see that word average, so it's going to be average value of the wire. Estimate the average temperature of the wire using a trapezoidal sum with 4 subintervals located. Okay, so the whole length of the wire is going to be 8 centimeters long. So it's going to be 1 over 8 times the integral of from 0 to 8 of T of x dx. We're going to leave this 1/8 on the outside, and it says we want to do 4 subintervals. So we're going to do our delta x's 1, 4, 1, and 2. Okay, so I'm going to go through and write these numbers down real quick, and so I don't mess up talking and writing at the same time. So this is exactly like the last question we did. And when you're working through these, I would copy this stuff down in your notes first, the problems. And, you know, maybe you want to try and work them out first. That's fine. And pause after every portion, you know, in case you need to write it down and make sure you understand everything. So putting this in the calculator, you get 75.6875 degrees Celsius. Okay, so let's know the average temperature over the length of the wire. Okay. Part C, it says, find the integral from 0 to 8 of t prime of x dx and indicate units of measure. Explain the meaning of the integral in terms of the temperature of the wire. Okay, so for portion C, remember, when we integrate the derivative, that's equal to t of 8 minus t of 0, according to your first FTC. Okay, so t of 8 is equal to 55, and t of 0 is equal to 100. Okay? So what this means is that the temperature changes 45 degrees over 8 centimeters of wire. So we write that out. The temperature changes negative 45 degrees Celsius over 8 centimeters length of wire. Or if you want to say the temperature decreases 45 degrees Celsius over the length of the wire, that's fine. Part D, I'm not going to even bother writing this down because I didn't understand the explanation that they gave. It says, are the data of the table consistent with the assertion that t double prime of x is greater than 0? Okay, the second derivative means that it's concave up. In order for something to be concave up, it's going to have to go from decreasing to increasing at some point in time. So it would look like this if it was concave up. You know, it would have some sort of point that looked like that. But all our function is it's decreasing the whole entire time, okay? So I would say that that assertion is not true. Because t of x is decreasing and the slopes are negative. I didn't get the explanation, so I'm not going to waste any more time on it. Okay? And that's it for AB. BC, we have a Taylor series and convergence problem to do. Okay. So it says, find the interval of convergence for this power series. Show the work that leads to your answer. Okay. So what we're going to do first is we're going to take this series and we're going to write it out. So it's the series from n is equal to 0 to infinity of n plus 1 over 3 to the n plus 1 times x to the n, because it gives you the general term, you know, all the way to the right. So that's my power series right there. Now, to find the interval of convergence, we're going to do ratio tests. So the limit as n goes to infinity of n plus 1, a sub n plus 1 over a sub n. So we're going to add a 1 everywhere there's an n. And then we're going to multiply by the reciprocal. Like that. And then we're going to break it down. And we're going to do a whole bunch of canceling. X to the n. Delete. I left that off. Sorry, I left that off. Okay, so we're going to cancel a whole bunch of stuff. Now, we're doing the limit as n goes to infinity, nothing else, not x. So, as n goes to infinity, this is the same power, so it's going to go to 1, okay? A 3 will cancel, and we're left with a third on the bottom, so this limit goes to 1/3. And we leave the absolute value of x, and it's less than 1 to converge by ratio test, okay? Now, we isolate x, we isolate the absolute value, and you get 3. So your radius of convergence, when we do this, r is equal to 3. Now, to do your possible interval of convergence, we drop the absolute value bars and we sandwich it in between like that. So we have to choose each endpoint. So for x is equal to -3, we plug into the series up here. Okay, so we get n plus 1 times -1 to the n times 3 to the n. So I'm splitting it up. Okay. So what I did is I plugged in my x value, -3, in right here. And I split it up. So I get the series from -1 to the n times n plus 1 over 3. Now I'm going to use all my series tests that I know. If I use the test for divergence, this thing is, if it's an alternating series test, it's not going to go to 0 because this is top heavy. But it's going to diverge by test for divergence. Because this thing's going to alternate between positive infinity and negative infinity, positive infinity and negative infinity. Okay? Now, for x is equal to 3. Okay, so for x is equal to 3, I'm going to plug in right here, and I get n plus 1 times 3 to the n all over 3 to the n times 3 to the 1. And so the 3 to the n's will cancel. And I'm going to have the same sort of situation going on with this one. Okay, so the limit as we take it to infinity, it's going to diverge by the test for divergence. Okay, so your interval of convergence, there's no equal to sign. If it was to converge, you would put an equal to sign right there. Okay? Part B. Let's see if I can run out of room on this. Okay, so for part B, it says you want to evaluate the limit as x goes to 0 of f of x minus 1/3 over x. Okay, so if I was to plug in a 0, f of 0 from our Taylor series is 1/3. Okay, so 1/3 minus 1/3 So we get 0 over 0, which is going to be a L'Hopital's rule. Okay, L'Hopital's rule says we're going to take the derivative of the top and the derivative of the bottom, and we're going to plug in our limit. So f prime of 0, we read from our Taylor series. So we know that Taylor series form goes f of 0 plus f prime of 0 times x, you know, that sort of thing. And it continues on. So the answer to this is 2/9. See, there's a 3 squared right there, so don't forget that. Okay, part C. It says, write the first 3 non-zero terms and the general term for the infinite series that represents the integral from 0 to 1 of f of x dx. Okay, so the integral from 0 to 1 of f of x dx. So if I was to integrate the first 3 non-zero terms, I'm going to get 1/3 x plus 1/9 x squared plus 1 over 27 x cubed. Okay, so I'm just adding 1 to the exponent, dividing by the new exponent for those 3 terms right there. Okay, now it says you want to evaluate it from 0 to 1. Okay, so if I plug in a 1, I get 1/3 plus 1/9 plus 1 over 27. If I plug in a 0, I get 0. So putting this in the calculator, okay, so you get 1117 over 2493. And it says you want to integrate the general term. So I'm integrating this term right here. So your general term is going to be x to the n plus 1. So we're adding 1 to the exponent right here, and we're dividing by the new exponent. And I still had that in front. So that ends up canceling. Okay? So that's all you're left with to do right there. Part D, it says find the sum of the series determined in part C. Okay, so part C is right here. So I'm just going to go to the back real quick and write it. Part C, we got 1/3 x plus 1/9 x squared plus 1 over 27x cubed. Okay, so when we're dealing with series and sums, we know a lot about geometric series because we've done a lot of those. Okay, so this is a geometric series because your terms are being multiplied by 1/3. Okay, so your r is going to be 1/9 over 1/3, which comes out to be 1/3. Okay, now to find the sum of a series, it's a over 1 minus r. Your first term, the first term that you're going to have, if you go back to over here, your first term's 1/3. And we are going to do it 1 minus your r is 1/3. Okay, 1/3 over 2/3 comes out to be equal to 1/2. Okay, and you can also see that if you go to the original function, so our original function right here, these are going to be multiplied by 1/3 as you go, okay, on the bottom. So, anyways, that's pretty much it. If you wanted to write this as a geometric series, you could. So let's look at that real quick. You wouldn't want to do that because you got x's involved. But your first term's still going to be 1/3. Okay, so anyways, that's this video. I would expect something similar to this, probably involving Taylor series. It's probably going to have a graph or a function given to you, and it'll probably incorporate these types of tests for 2020 free response. So we're going to keep working on these Taylor series and series stuff. So I understand they're difficult. If you have any questions, feel free to reach out. Thanks. Bye.